The subject name is compiler design. We discussed some of the problems related to concept in this subject. Now, one more problem to solve technique in LR parser. Discuss about that is LR parser. Now, LR parser, the first, it is called as one type of bottom-up parsing technique. It is a bottom-up parsing technique. We know that there are two types. One is top-down parsing. Another one is bottom-up parsing. So generally, it is used to parse a large class of grams. So here in this LR parser, the L stands for left to right scanning of the input, and the R stands for rightmost derivation in the reverse. Whereas K defines the number of input symbols that is look ahead, which is used for the parsing the data. Here it is divided into 4 parts, that is LR0, SLR parsing, CLR and LALR parsing. What are the steps that is to be followed to consider this LR parsing? So here the first we have to specify whether the grammar is a context-free grammar or not. Here we have to verify the given grammar is context-free grammar. The second one, we have to check the ambiguousness in the given grammar. If it is ambiguous, to try to avoid the ambiguousness in the given grammar. And also the important one is, after verifying, we have to add a production that is called as augmented production in the grammar. Then find the canonical collection of 0 items, and then data flow diagrams, and then parse table implementation. Data flow diagrams and then parse table implementation. So like this, we are going to verify this as a implementation of this tool first. So here, the construction of LR parsing table. In this example, the production is given one production and second one is this. Now, we know that according to the step procedures, ambiguity is not there and it is a context-free grammar. Now, we have to provide an augment production. So, this grammar, we have to add augment production, indicates that the dot symbol which is placed, that is the start symbol is S. So, that's why I have to consider S dash with the S. That is the production that is to be added, augmented grammar. And the remaining production as it is, we have to include. So, here we have been included S symbol S, and another have to include this one, and also as it is the remaining productions as it is. So, like this, we have been implemented this set of procedures as this one. Now in this, the first production, that is, we have to consider the individually we can write this one also. So that is A implies derives B. Now for this, we have to include a dot production. So that is the step augment production, then canonical collection. So this canonical collection of list items can be specified by implementing this dot symbol beginning of right hand side of each of the grammar. So this is to be indicated with dot S, dot AA, dot A small a, capital A, dot B. So this, in this way, we can say that this is the first production, second production, and this one is the third production. Like this, we have to give the numbers for identification purpose while implementing in the parse table. This is the step that is to be implemented as first. And the second step, here, what are the productions that is to be defined? That is to be here S dash dot S, S capital A, capital A dot, capital A dot, small a, capital A dot. Now in this is to be considered as a I naught. So that is to be considered as I naught first. That is the state I naught, which is considered as the given list of augment production with the first step of items. So these are the rules that is to be available in this. From this state, we can generate a new states by implementing shift and reduce. Here we have to find the closure of the each of the items. That is here capital S, capital A, small a, and small b. So we have to consider I naught with capital S, I naught with capital A, I naught with small a, I naught with small b. So this is to be considered with this one. If we consider I naught with S, the production S derives dot S will become S dash derives. So here after implementing closure operation, go to here this S, the dot symbol can be placed after each input symbol, one input. So here one symbol ahead it is to be placed. So here we get the result S derives S dot. Similarly, that is the state that is to be defined as I1. This state is called as I1. Next we have to find out I naught comma A. So that is to be declared here I naught comma S. So S is the closure which is performed on the state I naught, and we are reaching to the state I1. Similarly, another input A, and this leads to another state. But here what is A? S implies dot A. Now we have to perform the dot operation with each input one symbol head. So A dot capital A. But this A dot capital A, this is I naught comma capital A, will become S derives A dot A. Now what are the symbol it is available? So here after reaching dot there is no other symbol. So that's why we kept as it is. Whereas in this case, after the symbol input symbol dot symbol, there is still the symbols are available. Input is processed. So we have to consider any production who start with this one. So yes. So what are the production? A derives dot small a capital A derives dot b. So this is the consider as the list of processing states, that is I2 with this one. And if you consider this small a, this is small a, which gives the results as what is small a here. This is the small a. Now if you consider small a, that is I naught comma a, the production A derives dot A will become will be A derives small a dot A. But here the symbol is after dot, there is once again the term variable appear. So whatever the variable which belongs in this given productions are A derives once again small a dot A derives dot B. So we have to list out this one and make this state as I3. And another one is we have completed this and I naught with B. So what is the closure of I naught with B? So here this production is A derives dot B. It will become A derives B dot. So here after the dot symbol there is no appearance of any of the variables. So we can stop the procedure and make this one as new state. So that's why here we can trace a new state I naught B. We are getting a new state that is A derives B dot. We have stopped this. Now we got the states I1, I2, I3, I4. Out of this I1, I2, I3, I4, I1 reached I1 reached end state, and that means here dot symbol is after dot symbol, there is no further symbol, then we can say that it is the end. So that's why the state is to be stopped at this point of time, where I2 is not, I3 is also not, I4 is also reached end. So what are the states that cannot be not reachable and can be further applied the closure operation between this one. So here once again we have to process the remaining two states, that is I2 is one state and I4 is one state, that can be still further possibility of improving this input symbol dot operation one more ahead time, so that it leads to the end point. So that's why here what is I2? I2 equal to S A dot A derives small a dot A derives dot B. So this is the S2 state. Now this state we are going to perform small capital A, small b. So after performing this I2 comma capital A with this A dot A will become what is the closure? If you perform the closure operation of this I2 with A, then this production will become, so what is this? S derives A dot. So it reaches the end symbol, so that's why we can place it as I5. We have processed I5 and we are going to stop this procedure. Why? Because at this state there is no further input processing, further variable is not appearance of available. So that's why we stop. Whereas if you consider this same I2 with next one small a, the closure operation if you perform, so this is will become, in this case, the operation that is possible A derives small a dot A. So here the after period, the variable that appears is A. So still the input, still the productions are required. The corresponding one is A. So what are the corresponding productions in the given state? For A belongs, so these are the two. So that is to be included once again in this one also. So that's why A derives dot B. So this is becomes one state, new state, that is one new state, but this state is already which is available in I3. That's why instead of writing a new state I6, here we can write as small a, which belongs to the same available in I3. So previously I3 is available, so same I3 A derives A dot A derives small a dot A, capital A derives dot B. So that's why this is to be, instead of writing a new state, we can write a transition with input A, with A, because I2 closure operation I2 comma A, which gives this result. So this result is which is same as in I3. So that's why we have to process with the transition A to the state I3. That is no need to repeat once again. So we have already written capital A, small a, and next one is closure we can perform with I2 with B, small b. Now if you, what is small here? A derives dot B. It will become what is this? A derives B dot. Now this state is also already available, that is I4. So that's why instead of writing a new state number, we can process a transition like this with B input and with B, I2 comma B, which gives to I4. So we have processed to capital A, I5, small a, I3, and I small b with we get I reach it to I4 state. Now I2 is completed. Similarly, we have to perform I3. What I3? I3 also, I3 here, A derives instead of this I3 will contain, so I2 we have completed. So we got I5. I5 is no more further processing of this one. It can be stopped as it is. And I3, A derives small a derives small a dot a. These are the I3. Now if we perform I3 with once again capital A, small b, I3. So here capital A, if you perform I3 with capital A, so what is this? The A derives small a dot capital A will become what here? Small a capital A. So this will be state is I6. We can make it as I6. So after with A, I3 with A, we are getting this one. So we can stop this procedure, that is I6. Whereas I3 with small a, what is I3 with small a? The same. A derives small a dot to get this one. Now this is become same state. Why? Because the rules which we are getting the production which will be same as in the same I3. So that's why self transition we can make. Whereas I3 comma B. So this B which gives the I3. So I3 I4, that means same result as I4. That's why we make the transition as B. So in this way we can assume that the states are reached to the corresponding levels of that one. So finally all the states are end up with the dot symbol. So if you consider I2, I1, I2, I3, I4, I5, I6, all the states are reached to that level. So we can stop this procedure for completing the data flow diagram, and we can implement the pause table for this one. So in order to implement the pause table, first we have to write the two parts. One is action part and second one is a go to part. It divides them into two parts. This section divides them into two parts, action part and go to part. Now in this action part, go to part, we have to consider I naught with that is I told I naught comma S, I naught comma capital A, I naught comma small a, I naught comma small b. So this is rating stating I1, this is I2, and this is I3, and this one is I4. Now that's why here these S and A, these are called as non-terminal variables. So at go to part side, we have to write all the non-terminals in the given grammar. What is the given grammar? S derives dot S, S derives dot A derives dot A, A derives dot B. So in this one, capital S, capital A, these are non, whereas terminals, that is variables are to be written on the right hand side. Left hand side, that is terminals, not terminals. A, B, and dollar is to be written as added as a accepting state. So A, B, dollar. So the for this case, so that's why here the identification of this one R1, this is 1, can be mentioned as S, and 2, that is 2, state 2, that is to be mentioned as capital A in the row part. Whereas that is the first production, because state is I naught and the state is I naught, these two completed, and small a with 3. So what is small a? That shift 3 S3, and small b it is S4. So S4 we have to write. So this side we have to write S3, S4, and this is we have to write as variable across variable. A is 2 and S is 1. So like this, we have to complete the first row of this one. And whereas the that is first state I naught. So we have to write all the state name: I naught, I1, I2, I3, I4, I5, I6. We have to consider the states. And I naught state with this one can be implemented. Similarly, you have to observe the remaining states, each of the states for the corresponding variables and terminals, non-terminals and variables. Terminals and variables can be considered once again for the state I1. So I1 is the state which does not contain no more. So that is to be considered as accepting state because it is a dollar which contains the further processing is not available. It is to be considered as accepting state. Whereas I2, second I2. So I2 which contains I2 comma A, I2 with small a, I2 with small b. So this is the I2 state with capital A, small b and small a. No further divisions are there. So that's why here I2 and capital A it is reaching to I5. Small a it is reaching to I4. Small b it is reaching to I3. And small b it is reaching to I4. So that's why what is A here right hand side. So that is to be mentioned as 5. And I2 with the S3, S4. Why? Because this is the state reaching S3. So this is S4. Shift 3, Shift 4. We have to write third and fourth. Shift 3 and Shift 4. And that is the second state. And third state also we have to implement I3. I3 also process with capital A, small a and small b. So this the state with capital A it is reaching to I6, small a reaching to I3 and small b small b it is reaching to I4. So that's why here we have to write a capital A 6, that is in the row side row across the cell, particular cell we have to write 6. And for that corresponding row in the action side for I3 we have to write 3, that is S3 and S4. S3, S4 for the A on below column A we have to write S3 and below. Why? Because this terminal appears A and this terminal appears is B. So below A we have to write S3 and below B we have to write S4. Next one is state I4 state. So in this state we have to observe any other transitions are possible. No, there is no. It is reaching the end state. There is no other transition which is going from I4. Similarly I5 and I6. So these are considered productions are reduced productions. These are called as reduced production. So we have to verify these productions. What is I4? I4, what is the production that is available? A derives, in this case, A derives B dot. And what is I5? S derives A dot. And what is I6? A derives small a, capital A dot. Now in this list we have to consider the given one is 0, 1, 2, 3. So out of this, which of the production this is, that is third production is to be third production. Whereas A dot is which production in the given. So that is first production. And A small a, capital A, that is the second production. So that productions are to be written as in, across action part below all the terminals. So here I4 we have to write R3. So R3 A B dollar. Similarly R1 A B dollar and I6 second. So R2. So this is considered as R3. This is considered as R1. This is considered as R. So you know that These are the reduced productions. So third production is to be equivalent, so that's why R3. The first production is equivalent, so that's why it is R1, and the second production is equivalent, that is R2. So like this, we have considered this row I4 as R3, and this row means only up to action part, not go to part. Action part, the corresponding symbols R3, AB dollar, and I5 also R1 with AB dollar, and I6 also AB dollar. So this is the, like this, we have to write a parse table implementation for the given LR parser. This is a data flow diagram which represents the corresponding states, and we know that each of the processing state, and this is the step, that is last step, that we consider two types: canonical collection, argument production added, canonical collection, data flow diagram, and parse table implementation. So we'll come up with one more new topic, the problem solving technique.
Like, share and subscribe. Hit the bell icon for more updates.